Hello everyone, my name's Dr. Paul Rose, and in this presentation I'd like to talk to you about how we measure space in animal enclosures. How do we ensure that the space provided in the zoo is useful and therefore biologically and ecologically relevant to the species that's being housed? Space at the zoo is very, very important, but we must consider what we put in it, and we must consider how it's accessible to the animals. We need to consider the quality of the space provided to the animal, not just the quantity. Therefore, we have several methods available that can allow us to determine quality space, work out how animals use their space, where do they prefer to be, and which areas do they avoid. And this allows us to adapt and change our exhibits over time. Post-occupancy evaluation is a way that we can look at how an animal uses space once it's within its exhibit. We can evaluate space use by looking at how animals use particular zones or resources within an enclosure. We can then use those data to change or adapt the exhibit, hopefully making it better for the animals. And then we can use the same methods to see how they use their space after the change has been enacted. There are different methods of zoo enclosure usage that you can use. Post-occupancy evaluation can be performed by using a spread of participation index or an electivity index. All of these methods provide you with a numeric value as to how often the animals are using particular zones, resources, or areas of the enclosure that you have defined.
Resources within an enclosure can be limited but highly favoured. Splitting an enclosure up into these particular areas and knowing an estimation of how much they take up within the enclosure enables occupancy of such favoured areas to be measured and therefore compared to the animal's behaviour and its activity within different enclosure zones.
Resources within an enclosure can be defined as those accessible to the animals. Particularly when you've got mixed species within an enclosure, you need to consider whether or not all resources are accessible to all particular species. For the species that we house in captivity, it's really important that key features of their ecology are replicated in the enclosures that are provided. These gemsbok, for example, a savanna species, that particular habitat feature
needs to be replicated within their exhibits. It's essential that all of their functions can be carried out in the zoo in the same way as they would perform in the wild. Consequently, when we're designing enclosures for such species, natural history is our first port of call for such key information.
Sometimes it can be very easy to divide up an enclosure into particular zones. Again, zones based on resources. In this example, we've got a pool, we've got vegetation, we've got perching areas, we've got rocks for climbing, we've got a gravel beach, we've got nest boxes, and we've got a waterfall. We've got a range of different environments that have been created within the enclosure specific to these birds, and therefore the occupancy of these particular zones, i.e. access and usage of the resources by the inhabitants, can be mapped, counted or timed, and then the overall usage of all zones and its importance to the animal can be determined. We can measure how comfortable a species is in its enclosure based on how it's using its space and based on the types of behaviours it's performing. These sitatunga, relaxing and chewing the cud, suggest positive welfare within this exhibit.
Let's have a look at what we mean by positive welfare. These sitatunga have been provided with a range of biologically relevant resources and enclosure zones within the exhibit overall. The performance of this key welfare metric, i.e. rumination, suggests the animals are comfortable within the exhibit itself. The range of zones provided maps the natural history of this swamp-dwelling antelope. Here, the animals can move between a wetland area and an open grassy paddock. That open grassy paddock also contains areas of cover that the sitatunga use for resting and relaxation. The fact that other species within this exhibit are prevented from accessing the wetland enables the Sitatunga to use it without competition from others. Consequently, the ecological relevance in this exhibit is easy to spot. Estimate the area or size of each zone within an enclosure before you determine how to measure occupancy. Also consider whether you will be counting the number of individuals within each zone, or if you will be doing focal follows of particular animals that are identifiable. In this flamingo flock, it's probably going to be easier to count where the birds are and determine what's driving the usage of those particular areas. Features within an enclosure that can be classified as a zone don't have to be natural. Feeding areas, for example, where animals are provided with their daily diet, will naturally encourage grouping together within a part of the enclosure, and therefore their occupancy can be mapped the same as for naturalistic features. Consider how all types of enclosure zone group animals together in the same area. In this mixed exhibit of different water birds, the island is popular with all species.
Thinking about the value of a zone in an enclosure gives you an idea of how much animals will use it. For group living species, consider whether or not all individuals in the group can access the zone at the same time. This reduces competition and unwanted aggression and promotes stability and the social structure within the social environment.
Measure your enclosure area, know what features are within it, and know what features have been designed for the particular species kept. Again, this is particularly important for things like mixed species enclosures, where animals are sharing the same space. Once you know the sizes and dimensions of key areas, you can count the occupancy of the animals. This paper by Amy Plowman in the journal Applied Animal Behavior Science outlines the method of the Modified Spread of Participation Index that we can use to determine how animals use their space. The Modified Spread of Participation Index breaks an animal's enclosure down into unequal zones. These unequal zones are the areas or resources that are within the exhibit that are potentially accessible to the animal. It's important to remember that zones within an enclosure might not necessarily have been designed for the animal, but they are still within the animal's reach or availability for occupancy. Consequently, this breaking down into unequal zones enables the size and shape of the zone to be compared to the time the animal spends within it. For example, within this giraffe enclosure, the moat is clearly part of the exhibit, but is also being used as a boundary. Technically, it is accessible to the animals, although it's not likely to be used by them. We still should factor this in as a zone when we come to determining exhibit use, because this moat takes up part of the available space that these giraffes have within this enclosure. There are helpful examples within this paper on the Modified Spread of Participation Index, which explain how to split the enclosure into zones, what to do with areas such as boundaries or barriers that might be part of the exhibit, but not necessarily an area the animal is keen to inhabit, but they still should be included in any calculations. The Modified Spread of Participation Index gives you a value between 0 and 1. 0, where there is equal usage of all zones, and 1, where there is favoured usage of a particular area or zone within the enclosure. Changing the exhibit, modifying the features of the exhibit, and then recalculating the SPI for the enclosure enables you to determine why the animals like to be in particular areas and how their enclosure usage can be adapted. Other methods, as well as the modified SPI, are also available to determine space use, perhaps in enclosures where sight lines are broken down or features are provided to split up interactions between groups. An electivity index could be used to determine how often animals spend their time in particular areas based on where their conspecifics are. This work has been pioneered by Stephen Ross and colleagues at the Lincoln Park Zoo and has been used specifically for great ape behaviour and space use, chimpanzees and western lowland gorillas. Here we can see an example of a chimpanzee enclosure. It is a complex, diverse environment. Using an electivity index can enable the researcher to determine where the animals like to be and what might be causing them to be in that particular area. Is it the enrichment, the substrates, conspecifics, or other enclosure features that are driving where the animal is found within the exhibit itself? Again, this paper is found in Applied Animal Behaviour Science and details the methods used on captive populations of chimpanzees and gorillas at the Lincoln Park Zoo. This paper explains the methods used as well as the results that you get from an electivity index, and it also compares two forms of exhibit, an older style of exhibit with a newer style of exhibit, to show how usage of calculations of space use is relevant to comparing what exhibits provide to the animals and how we can therefore infer welfare state from such measurements of space use. With complex, highly social species like great apes, it's important that animals are provided with opportunities for choice and control to move away from or be with conspecifics, as well as choice over the resources they have access to. Multiple high-value resources within an enclosure limits unwanted aggression, reduces group conflict, and encourages social stability. Consequently, when we come to measure how animals use their space, ideally we do this in conjunction with measurement of individual behaviour too. Construction of time activity budgets using scan, instantaneous, or continuous sampling is really relevant to how we get an holistic picture of all of the features that are influencing space use for those particular animals in that particular exhibit at that particular zoo. This short presentation has explained why measurement of enclosure usage is so important to our understanding of zoo animal welfare. The methods that have been documented, the SPI and the electivity index, are both useful to different species in different environments and provide the researcher with an empirical set of data that can be compared across individuals and populations over time.